Hi guys, welcome to my channel. I will be focusing on electrical circuit, which is a grade 12 topic. It's very easy. It only requires a practicing. This topic has got three definitions that you only have to know. There are other definitions, of course, some other concept, but this topic will only come with three definitions only that you have to know in grade 12. The first one, you have to be able to state Ohm's law. So the definitions are as described in the exam guideline. The first one is Ohm's law. Ohm's law is stated that potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So I'm starting, this is my very first introduction in electric circuit. I'm starting with the background, the definitions, what you have to know, the concept that we will have to use as we solve problems containing electrical circuit. So it says that potential difference, it is across the conductor, is directly proportional to the current across the conductor. So for Ohm's law to be valid, the resistance of a conductor has to be constant, and a resistance of a conductor can also only be constant if a temperature across a conductor is what? Is constant. So V is equals to I times R. This is known as what? As Ohm's law. So the second definition which we have to know, when this definition comes in exam, will come with 2 marks. This is the first definition. The second definition is internal resistance. There is a resistance in the external circuit and resistance inside the cell. So that resistance inside the cell is called what? Internal resistance. So it can be defined as follows, as per exam guideline. You say the resistance charges experiences when passing through a cell. This is the resistance charges experiences when passing through a cell. So the symbol for internal resistance is a small letter R. So the symbol for the resistance outside the cell or anywhere in the circuit is a capital letter R. Sometimes this resistance outside the circuit can be denoted by R external to show that this is a resistance outside the what? Outside the circuit. So as we proceed, the third definition that you have to know in grade 12 in physical science, as far as the topic of electrical circuit is concerned, is EMF. EMF is denoted by this letter. As you can see, there is sort of an E. So is the total energy supplied per coulomb by a cell. Total energy supplied per coulomb by a cell. So as you know, internal resistance, that is the resistance, there is charges experience when passing through a cell. So it is measured in what? In ohms. Resistance, of course, is measured in what? In ohms. So the third definition that you have to know is the EMF. And EMF that is the formula for EMF. Let us do some play around with this formula of the EMF. EMF can be given by I, R, I. This is the total current anywhere in the circuit. So total current in the circuit inside the battery and also inside in the circuit is what? In the external circuit outside the battery is the same. So I is a common factor here. We can write this formula as IR. So EMF is given by I. This is V load. This is the voltage outside the cell in the circuit, but outside the cell. So it can be given by V load. Can be called V load. As you know that I times R is voltage. Voltage is measured in volts. Then we say plus V internal. V internal is the voltage inside the cell. So IR, as you remember, is the internal resistance. So V load is the voltage outside the cell. It can be expressed as V load. Can also be written as V external. V external. At some point, that's what V load can be written as. We also have got V internal. V internal can be written as V lost. This is the voltage used to overcome the resistance of the battery. So these are one of the most important concepts you will have to know when we are dealing with electrical circuit grade 12. There are more formulas I will bring. I want to introduce the formulas to calculate power and energy as you know them in grade 11. As you can see there, I have just drawn the diagram of a circuit. So this circuit has got the important components which I was just explaining earlier. So this one is the internal resistance. The cell, our cell has got internal resistance. It is represented by small letter r, and we have got R external, which is the resistance in the external circuit. External circuit. This is the circuit outside the what? Outside the cell. So the EMF, which is the total voltage from the cell when the switch is what? When the switch is open or when there is no current flowing. So when we open this switch, the voltage, the reading of the voltage will drop because some of the voltage is being used to overcome the internal resistance of the what? Of the cell. So in this circuit, we have to worry about two resistance. The resistance inside the cell and the resistance what? Outside the cell. So according to the formula of the EMF usually it can be EMF, it will be a value. It is measured in volt, electromotive force. It is I R plus I capital letter R external plus small letter r. So EMF is being used to overcome the resistance of two resistors. The resistance inside the cell, here it is, and resistance outside the what? Outside the cell, here it is, as you can see there. So, and then we can say, or we can write this formula in this form: IR is equal to V I plus IR. Remember, this is our V external. V external is also called what? V load. Then we have got V internal. V internal. This is the voltage of the internal what? Resistance. So that is what we have. Then as we proceed, there are some formulas we also have to know. We can be required to calculate the I'm sorry about this. This is the ammeter. This is the ammeter and not voltage. This is the ammeter. So as you can see that we've got work. Work can be work or is energy. Sometimes they refer to it as energy. Sometimes we can be required to calculate the energy dissipated by this component, which is the resistor. In this case, this component, sometimes it would be the energy dissipated by or supplied to a bulb. So it can be a resistor in some case, or a component can be a bulb or any other electrical component. So the formula is given by work. Remember, this energy will be measured in joules. It's equal to V, which is the voltage. The voltage across this component is what? Q. V times Q. So Q is the charge. Charge can be given by. So we know that charge is given by, but we know that Q is equal to I times T. I times delta T. Remember, current is the rate of flow of charge. Current is the rate of flow of charge. So we have got charge and what? And time. So we can going to replace this T by this charge here by Q. So we've got energy is given by V over times I times T times I times delta T. So remember, time in seconds, voltage. Our voltage must always be in volts. Current is always in amperes. Current is always in amperes. Current is in amperes. Voltage is always in volts. So our time has to be in seconds. Always make sure that your time is in what? Is in seconds whenever you are doing these circuit calculations. Then as we proceed, this is the formula to calculate work or energy dissipated. Remember that from Ohm's law, we have got V is equals to I R. V is equals to IR. So let us replace this V by IR. We've got work is given by V is equal to IR is R, then that is what we have, and I times delta T. Then we've got work is given by I times I is I squared times R times delta T. So this formula can be calculated in this, also in this instant. We've got the first formula and then the second what? The second formula to calculate. We've got the very first formula here, which is not normally used in grade 12, but the second and the third are used usually used in what? In grade 12. So also from here we can replace this voltage by resistor, this current by let us say we are given voltage, then we're going to say that we want to replace the current, then we are going to say I is equals to V over R. So from this formula we can write it as work is given by V over the current is given by V over I, then I add another V over R times delta T. Then we've got work is given by V squared over R times delta T. So here we have got the three formulas we can expect to come across in grade 12 whenever you are required to calculate the energy dissipated by a certain electrical component or the energy supplied to a certain electrical component. It is measured in joules. So we can expect to see these three formulas in the formula sheet. So these are our formulas. So from these formulas, I'm going to show you how to calculate, to derive a formula for power, from work to power. Remember, power is the rate at which work is done. So I want to show you how we can derive the formula for power from the formula of energy dissipated by electrical component, sometimes referred to as work. So power, remember from the concept of work, energy, and power, we have got power is given by rate at which work is done. Power is measured in watts, capital letter W. So remember, power is the rate at which work is what? Work is done. So let us see how we can derive the formula of power from the following three formulas. We want to know how we can calculate power when given energy or work. So we can say power, remember, is the rate at which work is done. So work is given by, in the first case, work has been expressed as V over I times delta T, and over delta T. So we cancel out the delta T, cancel out. Then it goes on to say P is equals to V times I. So this is the first expression for power. We can calculate power as this is voltage times current. So this is the first expression you can use in grade 12. Of course, it will be there in the formula sheet. I just want you to have the background before we go to solve more problems, or from this topic. Then the second equation, also remember that we still say power is the rate at which work is done. So we can say power is equals to current, sometimes we I squared, and then it goes on to say R times delta T. Then we just divide the delta T. Then it says power is given by I R squared. That is what we have as I squared times what? Times R. So that is what we have. So as we proceed, we can also say power is given by, I'm just going to divide everything else there by time. Say V over R, and then we divide by delta T, and then we have got delta T. So here are the last formula you can use to calculate power. Then this is the one of the three formulas, and this is one of the three formulas. So those formulas are given in the formula sheet. As you know that we have to know how to calculate energy dissipated or supplied to an electric component, and then we also have to know how to calculate power. If we know the voltage of an electrical component, also we know its current passing through that electrical component, we can calculate its power in watts. So that is what we have. So we are going to use every single one of the formulas I have just outlined to you to solve electrical circuit problem. And I would like our very first problem in electrical circuit to not include internal resistance, so that we can have the background or revision of what or how you used to solve electrical circuit problems in grade 11. It will be there in my next videos. Thank you guys. You will see how we solve our next circuit problem, our very first circuit problem in my next videos.